Topic 13.5 Equations of motion in normal tangent coordinates. Today's objective is to apply equations of motion, that is sigma f equal to ma, in normal tangent coordinate system. We use normal tangent coordinate system when the particle has motion along a curved path. And when that happens, we define tangential axis along the motion of the path or tangent to the curvature of the path. Normal axis always towards the center of the curvature, and binomial axis which is perpendicular to both of them. So the normal component of the equation of motion is written as sigma f equal to man, where sigma fn is referred to as the centripetal force. So when particle has motion along the curved path, it experiences centripetal force, and that force is sigma f equal to sigma fn, sum of the forces along normal direction. The positive normal direction for the normal tangential coordinates is normal to the tangential component. It's always directed towards the center of curvature, and also normal to the binormal component. That means the correct answer is all of the above. You can see that here, that normal is perpendicular to tangential, is perpendicular to binormal, and points towards the center. Few applications of normal tangent coordinate system. So racetracks are often banked to reduce the frictional forces required to keep the cars from sliding up to the outer rail at high speeds. So when the cars make the turn at high speed, cars experience centripetal force in the normal direction. Now to prevent the car from sliding up the ramp, the roads are banked so that the friction force acts in the opposite direction, and it prevents the car from sliding up the ramp. So if the car's maximum velocity and minimum coefficient of friction between the tires and the tracks are specified, how can we determine the minimum banking angle theta required to prevent the car from sliding up the track? And we can do that by applying sum of forces in normal direction is equal to mass time normal acceleration, where sigma fn will include centripetal force and the friction force, as well as an will include v square divided by radius of curvature. So once we have all this information, we can calculate this minimum angle theta. This picture shows a ride at the amusement park. The hydraulic powered arms turn at a constant rate, which creates a centrifugal force on the rider, which is like this force. We need to determine the smallest angular velocity of cars A and B such that passengers do not lose contact with their seat. What parameters are needed for this calculation? So we need to know what is the velocity of the this amusement ride, what is the radius of the curvature, and what's the weight of the passenger, and then based on that we can apply the equation sigma fn is equal to man along the normal direction and calculate the smallest angular velocity of the cars. Satellites are held in orbit around the Earth by using the Earth's gravitational pull as the centripetal force. The force acting to change the direction of the satellite. So see, there are two types of force, centripetal force and centrifugal force. Centripetal force is towards the center, and centrifugal force is experienced because of the inertia away from the center. So that's the difference between these two. So if this satellite at certain kilometers above the surface of the Earth needs to be retained at that point, and it should keep orbiting the Earth, then it should have certain minimum velocity v. Because this, if we define that this direction is normal direction for the satellite, the force experienced by the satellite in the normal direction is nothing but the weight or the gravitational attraction because of gravitational pull because of the Earth's gravity. So that W is equal to MAN. Now W is mg, so mg is equal to MAN, and AN depends on V square divided by radius of curvature, and mg is equal to M v square divided by radius of curvature. So we get v is equal to square root of radius of curvature multiplied by g, where g is the gravitational attraction and the radius of curvature is this 80 megameters. So if we know what is at what height the orbit satellite is orbiting the Earth, we can calculate the minimum required velocity vb. If the velocity of the satellite is less than this velocity, then the gravitational force it experiences will be more, and eventually it will like fall on the surface of the Earth. Okay, so knowing the radius of the orbit of the satellite, we need to determine the required speed of the satellite to maintain this orbit. What equations govern this situation? So this is sum of forces in normal direction, and this is the final equation. So once again, normal tangent by normal coordinate system. So particle is going through this curved path at any given instant p. Particle has experiences tangential acceleration, which is sigma ft equal to mat. It experiences normal acceleration, which is sigma fn equal to man, and this is sigma fb. Now there is no acceleration along binormal direction, so sigma fb equal to 0 for normal tangent coordinate system. Particle has motion only in anti-plane. It does not move up and down in the curvature. It's not a three-dimension curvature motion, it's a two-dimension curvature motion. The sum of forces in binomial direction is 0. Okay, so tangential axis is always tangent to the path and points in the direction of motion. Normal is perpendicular to tangent and always towards the center, and binormal is perpendicular to both of them as per the right hand rule. Okay, so this is our vector equation. It can be written as components of normal, tangential, and binormal forces using this equation, and then we can separate this into three scalar equation, that is sum of forces in tangential direction is equal to mass time tangential acceleration, sum of forces in normal direction is equal to mass time normal acceleration. What we don't have here is sum of forces in binomial direction is equal to 0, because there is no acceleration in binomial direction, and these are our three equations of motion in normal tangent coordinate system. And in the next video, we'll solve a problem using these equations.